Point 2 here, solving inequalities by multiplications or divisions. To start this off, I want to show you this comparisons to see if you actually can compare. 4, 8, okay? So which one's bigger? It's not really that hard to tell that 8 is the bigger value. So therefore, the mouth of the symbol is facing 8, right? That's very simple comparison. So now this time, I'll let you go ahead and take each value here and try to multiply each side by the same -2. So I'm going to take -2, multiply that by 4, and I'm going to take that same -2 and multiply that by 8 as well. Okay, so notice it's the same exact example, but now I'm multiplying each side by -2. How's that going to change? So this time it's going to become -8, and on the right hand side it's going to become -16. Now I'm going to ask you the same question again. Which one is bigger? Okay, now as we know that the more negative number, the smaller the value. So therefore, this time -8 is actually bigger than -16. Okay, now same exact problem again. Here's the 4, here's the 8. This time I want you to go ahead and try to divide each by -2 and tell me which one's bigger. Well, 4 divided by -2, as you know, is -2. And 8 divided by -2 is -4. And once again, since the -2 is the closer to 0, so therefore it's actually bigger than -4. So through these two examples right here, what do you notice about dividing or multiplying by a negative value? Well, we know that whenever you multiply or divide by a negative value, your symbols actually got switched. It's not the same way before. The reason you have to forcefully flip your symbols, because if you keep it the same way, it won't be true anymore. So you have to actually flip that to make it true still. You see, you kind of see why it has to be flipped, right? So try to keep that in mind, that when you try to solve an inequalities by multiplication and division, and that when you have to involve dividing or multiplying by a negative value, you will end up having to flip your symbol just to make sure that the final result is true. Okay, so take a look at this example right here. I have -7 greater than r over 7. Okay, so how do we solve for r? It's quite simple. We have to get rid of this. It's r divided by 7. We can certainly multiply both sides by 7 to get rid of it. Or we can set up a -7 over 1, and we can cross multiply if we want. It doesn't really matter. We have so many ways to do the same thing. But this will get rid of the 7 for you. And on the left hand side we have -49. Okay, this time we don't have to flip anything, because notice that we are multiplying by a positive, not a negative value. And I want you to write this back as a solution set. So using the notation right here, here's the r, such that r, once again, the mouth is facing -49, so that means -49 is bigger, so r is less than -49, right? So to close it, notice it's still exactly the same, not changing anything. R is still less than -49. That's how we represent it. Okay, so go ahead and try this example yourself. B over 10 less than or equal to 5. Don't forget, we only flip the symbol when we divide or multiply by a negative value. Okay, so here is an example of that. Pretend that I have -5/8 times y greater than or equal to -15. Okay, now if we want to go ahead and get rid of this -5/8, we have to we can certainly multiply both sides by its reciprocal, which is -8 over 5. Okay, and in the process of doing that, we will get rid of the -5/8 over here. And hopefully you still remember, because we're getting rid of this by multiplying by a negative value, we got to flip our symbol. Okay, now once we're done flipping, on this right hand side, both of them become positive. 15 cross cancel is going to give you 3 right there. So 3 times 8, 24. Okay, y is less than or equal to 24. To represent that, we have y such that y is less than or equal to 24. Now to test to make sure it's true, let's pick a number. 0. Again, anything that's less than 24. Pick a 0. So 0 is less than that. So if I plug it in, 5/8 times 0, is that still going to be greater than negative 15? Indeed, it's true. So we know our answer is correct. So don't forget to test it at the end as well. So I want you to go ahead and try this next example yourself. Negative a over 11 greater than 9. Okay, so try to solve for a. Don't forget, if you don't see a coefficient in front, you can certainly replace that with a 1. Okay, just to kind of help you with that. Here's the last example of this one right here. I have 32 greater than or equal to negative 2y. And since I want to solve for y, I have to get rid of this negative 2. Getting rid of this means I have to divide both by negative 2. And so y, let's say I forgot to flip. I keep the same exact symbol, okay? So it's going to become negative 16. So my solution here is going to state as there exists a y such that y is, don't forget, less than or equal, because the mouth is facing negative 16, less than or equal to negative 16. So this is what we assume the answer is, okay? Remember I told you I forgot to flip the symbol, right? I know I'm dividing by negative. I just go ahead and you know, solve the problem without flipping it. So let's try to check to see if it's true. Here, based on the solution set, I said y is less than or equal to negative 16. Anything less than negative 16 is going to be on the left-hand side. So let's try negative 20. Negative 20 is on the left-hand side of negative 16, right? It's less than negative 16, so let's try negative 20. So I'm going to use that and plug it right back into my inequality. Negative 20. So if I solve for that, here's 32. Negative 2 times negative 20 is going to be 40. And right away, notice that 40 is not less than 32, so this is not true. Something must be wrong here. And you know why, because when I divide by negative 2, I did not flip the symbol. It should be like this. Y is actually, when I flip the symbol, it's going to be negative 16 less than or equal to y. Okay, so that is the actual answer. Don't forget, notice that I flipped. And then when you represent that as a solution set, it should be there exists a y such that y is greater than or equal to negative 16. Now this time when you try to put it back in and then try to test it, it will be true. Okay, but don't forget, whenever you divide or multiply by a negative value, during your last step, you need to flip this symbol. So I want you to go ahead and try this one now. And we'll check the answer when you come back.